Like and subscribe and click the bell icon to get new video updates.
We've seen the black hole called Sagittarius A at the middle of the Milky Way. Now what? There is a monster twirling around in the center of our galaxy, and its portrait has finally been unveiled. Overnight, the International Event Horizon Telescope, ET, crew revealed an image of superheated gas coursing around and falling into Sagittarius A or Sgr A, the supermassive black hole in the Milky Way's core. It is the culmination of 5 years of simulations and data crunching. And while it might look a bit like a glazed donut, there is more to the new image than meets the eye. Space to play or pause, M to mute, left and right arrows to seek, up and down arrows for volume. For one, it tells us the black hole is 4 million times the mass of the Sun, a figure physicists suspected, but is now confirmed. The black hole is spinning too, but its skew whiff, slightly tilted face onto us. But despite this veritable goldmine of information about our galaxy's black hole, there is still plenty we're yet to discover. What is so special about Sgr A? Well, for one, it is our supermassive black hole. It is home, said Jessica Dempsey, an Australian astrophysicist and member of the ET team. Read more that is why this one is special to a lot of people. The hunt to understand what is going on at the center of our galaxy is hundreds of years old. And while it may not be the biggest black hole, Sgr A's proximity means it is our best bet for understanding how it and its counterparts behave. As our instruments on the ground and in space improve our understanding, the Milky Way black hole is going to go a long way to unpacking general relativity, and how that works with quantum mechanics, said Dr. Dempsey, former deputy director of the East Asia Observatory in Hawaii. Understanding more about the Milky Way's hefty heart can give clues as to how our galaxy formed. And maybe what we can learn from Sgr A we can start to look for in other galaxies, she said. An energy inefficient giant. One of the biggest ongoing questions in black hole physics is exactly how they collect, ingest and expel material orbiting them at near light speed in a process known as accretion. Read more. This process is fundamental to the formation and growth of planets, stars and black holes of all sizes, throughout the universe. Despite the brightly spiraling gas and dust in the image, Sgr A was not eating as much matter as the team had expected. If Sgr A was a person, it would consume the equivalent of eating a grain of rice once every million years, said Michael Johnson, an astrophysicist at the Harvard and Smithsonian Center for Astrophysics. While some black holes can be remarkably efficient in converting gravitational energy into light, Sgr A traps and hangs onto nearly all of this energy. It converts only 1 part in 1,000 into light, Dr. Johnson said. And unlike the gargantuan black hole in the galaxy M87, an image of which was released in 2019, Sgr A is not blasting an enormous jet of X-ray energy into space. But it might have a weak jet, Dr. Dempsey said, based on as yet unexplained peculiarities in how it rotates and accretes matter. If a jet is indeed there, the ET can't yet see it, but research published late last year suggests a weak jet might be present. While the ET was gazing at the black hole, 3 X-ray telescopes kept an eye on it too. They spotted X-ray flares, or outbursts, from Sgr A. Signs of a jet? Perhaps. Black hole blanks to Phil James Miller-Jones, an astrophysicist at Curtin University and the International Center for Radio Astronomy Research, said measuring the polarized light thrown off by the black hole's surroundings would tell us about its magnetic field. It is something the ET team reported, last year, about M87. Sgr A seems to have a strong, dynamically significant magnetic field, which means it is a magnetic field strong enough to affect the motion of the plasma around the black hole, Professor Miller-Jones said. It is going to be very interesting to look at that magnetic field structure and how that is influenced by the black hole, particularly given that it is spinning. Alistair Graham, an astrophysicist at Swinburne University of Technology, hoped to find out just how fast Sgr A's spin was. Black holes can spin at significant fractions of the speed of light, but I sensed the ET team was unable to get an accurate read on this. Another mystery that is yet to be solved is pinpointing the launch site of plasma jets that blew up the colossal twin bubbles in the Milky Way, he added. So how will we answer these questions? First, let us look at how astrophysicists managed to peek through a cosmic curtain of stars and gas to the black hole within our galaxy. Radio, lights, telescope, camera, action. Over a handful of nights in April 2017, when skies were clear, 8 observatories from Antarctica to Europe simultaneously focused there.